Hide the planet! Hide the planet! Shut up again!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs, it's me, the Shy Hat, and today we're doing co-working. We're going to be working on a C coding course, and everybody's free to hang out and work on their own stuff as well. I highly encourage it. And Jellipo says, I started with Hack the Box. Before I started looking for other learning resources, one that really got me motivated was Occupy the Web. I've heard of Occupy the Web before. Let's see if I can pull it up right now. Occupy the Web. It's all about Hackers Arise. Okay. So Occupy the Web, I think that's the name of the person, and Hackers Arise is their website. Right? I'm not sure if they have like actual exercises here, but I guess there's a bunch of resources. They offer training. Okay. Yeah, I'm not super familiar with this website, but I have heard of it before. Jallipo says, Hackers Arise's site. Okay, followed for a bit. Burnt out and messed around with a lot of Wi-Fi hacking for a bit. I mean, the nice thing about hacking is that if you get burnt out on one subject, you can always pivot to another. So if you get tired of network hacking, you can move over to cryptography, and if that's not working out for you, maybe do some digital forensics. All sorts of fun. All right, so what are we doing today? We're going to be doing this course over here. It's called the Learn C Essentials Part 1 course from edub.org. He sells a book too. Yeah, I think I've seen him interviewed by what's the name of that guy? David Bombal. David Bombal has a pretty big like tech YouTube channel, and I don't know if he still does, but he used to do a lot of like cybersecurity content. Linux Basics for Hackers. Yeah, I've heard of that book. I haven't read it myself, but I have heard of the book. All right, so while we're working on this course, I'm going to go ahead and put on a bit of music because it's a lot easier to study with a little bit of music on in the background. Let's go ahead and put that on and turn down the volume. Okay, he still does, David Bombal still does a lot of cybersecurity stuff, I guess. I mean, the guy runs a professional YouTube channel. He does whatever's going to get him a bunch of views, right? Oh, you own it. Awesome. Okay, let's go ahead and get started. If you have any questions about cybersecurity, if you just want to talk about stuff, I'm happy to talk while I do my studying over here. What were we doing? So advanced string manipulation, getting words on the screen, printing on the screen. So a palindrome is a word that reads the same backwards or forwards. Write a program that takes in one word and prints its palindrome. Didn't we finish this? Hold on. I thought we finished this already. Yeah, no. I finished this. I'm going to move on because I remember taking a long time to do this. Okay, congratulations, you finished Module 4. And let's see. So we did the switch instruction arrays. I've already forgotten a lot of stuff that we were studying in this particular module, but I guess I'm going to have to familiarize myself with it while I do the test. Initiators, simple pointers in the arithmetic, the difference between arrays and pointers, strings and string manipulation. Okay, I guess we will do the test, and I might not be able to finish the test, we'll see. Okay, Module 4 quiz. So this is going to take like 20 minutes. You know what I forgot to do? I forgot to put on my timer. So we're going to go at this for about 120 minutes, and we'll see where we're at after 120 minutes. The goal is to go on for about 2 hours or so. Not 2 hours, 3 hours or so. And hopefully we've got some good progress after that. You have double overlays. Yeah, I mean, that's actually intentional because there's only one topic for today. So we're just doing co-working and Hangout, and we're going to be working on the C coding course. Okay, so let's proceed. The test should take about 20 minutes, is it? I will not cheat, maybe. But I'm, you know, I'm kind of taking this a bit casually, not super seriously. So 20 minutes, 10 questions. Points to score 10. Passing score 70. So we need to get 7 out of 10 questions correct. Okay, so what happens if you try and compile this program? Okay, let's pull it up. So the options are the program outputs 2, the program outputs 1, and the program outputs 0. So I and j are integers. For I equals 0, so we're running a loop. I equals 0, I is less than 10. I iterates by 2. So I is at 0, and then 2, and then 4, and then 6, and then 8, and then 10. Okay, switch case I. Case 0, j increments and then break. Case 2, j increments and then keeps on going, and then case 4, j increments and then breaks. Default, j decrements. Okay, you can use that $1 to cheat if you want. Tattletale, hey, hello, nice to see you here, and thank you very much for the tip. I appreciate your super chat, and yeah, easy if you unroll the loop. So we just need to figure out what the loop is doing. Let's think about this. So at the end of the program, print out J. What's the and D? So the and D, this is a digit. So and D is format string or format specifier. So printf a digit meaning an integer, and the integer is going to be J. Okay, so it runs. So if I is ever 0, so I starts at 0. So I starts at 0, J increments and then breaks. Because it breaks, the rest of the loop doesn't happen. So that means that J is 1 when it's printed out. So the program outputs 1. Next. Okay. So this one is the program outputs 12 or 13 or 14. So I, integer I, and T, an array, an integer array of 5 elements. Okay? And for I equals 0, I less than 5, I increments, T, I equals 2 times I. So T of I equals 2 times I. So the first time I is 0, so T0 equals 2 times 0. 2 times 0 is 0, okay? I equals 0. I equals 0. So they reset I back to 0, and then... So what do they print out eventually? So at the very end, they print out I. At the very end, they print out I. Is this like a trick question? Jao Halapo says, what led you to studying the C language when you have time to talk about it? So C is very important for learning binary exploitation, as well as reverse engineering. So those low-level disciplines in cybersecurity really make use of C, because in reverse engineering, the reversing tools decompile programs into pseudo-C language. So you need to be able to understand the pseudo-C language. So that's where learning and knowing C comes in handy. And for binary exploitation, a lot of the beginner level binary exploitation challenges deal with insecurely coded C binaries. Okay, so I is reset back to 0, and then for I equals 0, I is incremented by T of I. Oh, okay. So this is where it comes in. So let's see. So 2 times I, so it's 0, then 2. You know what, I should probably write this down on like a scratch piece of paper, because it's like I less than 5. I mean, it's okay if I fail the test because I run out of time. It's all about understanding what's going on in the code anyways, right? So I equals 0, then, or like T equals 0. T equals 0, then T equals I times 2, which is 2. And then T equals 2 times 2, which is 4. Then T equals 2 times 3, so 6. T equals 2 times 4, which is 8. Then T less than 5. So 0, 1, 2, 3, 4. And does it run the 5th time? Less than 5. So when it becomes 5, it doesn't run again, right? Nullsec says, I just got here. I don't know what's being talked about. What was it about? General purpose, just a general purpose statement of fact. What are we talking about? You don't know? It's not okay. Let's not troll each other too hard, Nullsec. Okay, so I plus equals T of I. T of I, so it's going to be these numbers added together, right? So it's 2 plus, so that's 10, that's 20. This is 10, and then 2 plus 8 is 10, that's 20. 20 is not one of the options, of course. So T plus equals T of I. So T of I, so I... Am I not understanding something here? So T of I values. So I gets reset back to 0, and then it's I plus. So it is I plus da 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 da. Maybe. So the options are 12, 13, and 14. So I is 0, I less than 5, I increments. So I starts at 0 and then adds T of I, which is 0 and then 2, 0 and then 2, and then add 4, so that's 2 and then add 4, that's 6. 6 plus 6 is 12. So I'm gonna guess 12. Although we really shouldn't be guessing. Anyways, can you copy the code? No, this interface doesn't let me copy. At least I don't think so. Yeah, it doesn't let you copy. Okay, let's go on. So we only have 11 minutes left to answer like 7 questions. It's okay, we'll probably have to do this again. Okay, so again, our options are 14, 10, and 12. So integers I and S equals 0. Integer array T has 5 elements. 1, 2, 3, 4. Okay, the 5th element is missing. So far, for I equals 0, I less than 5, I increments. Increments 1, 1. I hate C. Well, I mean, the thing about C is that we have to keep on studying it so that we can understand it. So if we study it long enough and we study it hard enough, we'll understand. Or at least that's the theory. Okay, so ultimately we're printing out S. So S starts at 0, and then we populate it with this for loop. So for I less than 5, that's going to be 4 times. So T of I gets added to S. Ti, so it's 1 plus 2 plus 3 plus 4. So that's 7 plus 3, so that's 10. So I'm going to guess the program outputs 10. Okay, we just need to keep on going. Cheat? I mean, I guess we could cheat, but I think the goal of the exercise is to try to deconstruct the code. The answer with question 2 dirtied I in the second loop, so the correct answer was present. Cypher says C is perfect, C++ and C# just ruined it. I mean, there's I mean, I can jab with C. I think there's a lot of good stuff in C. It's of course I need to study it more, and then I need to study other programming languages to see how it compares. The thing about C is that C is the grandfather of a lot of different languages. Perfect has a lot of imperfect edge cases. I mean, nothing's perfect, but there's a lot of good stuff here. Okay, so it's either 44, 64, or 54. So I is 10, J is 20, P is a pointer, P is an integer pointer, and S equals 0. So P is the, what is this, the dereference of I? So the dereference of I, so whatever I is pointing at. So whatever value that I has. Okay, so I increments, and then the pointer is incremented. S equals I plus J plus pointer of P. Okay, when I'm having to run code, use code, I'm going to ask the AI. I mean, yeah, okay. The thing is that if you study a lot of code and you're doing something a little bit more complicated, it really pays to understand the language that you're dealing with. Like, I would be a lot less confident to run Python code if I didn't know at least some fundamentals about Python. I mean, I can run C code that the AI gives me, but I'm not as confident about it because I haven't done a lot of study about C. When Linux has their first programming language, don't say I didn't tell you so. I mean, are we talking about a programming language that's Linux? I guess the programming language of Linux is basically C, or it's either C or it's Bash. Okay, so S equals, so let's just make sure that nothing is being affected over here. So pointer of P is the dereference of I. So the dereference of I is, it should be 10. So pointer P points to something of I. CypherLogic says pseudocode is the most important language of any code. Pseudocode. Nullsec, Bloodhound start. I mean, we're not exactly in a Windows Active Directory environment, are we? Okay, so j is plus j, so j is definitely 20. I is 10, so that's going to be 30. 30 I increments, 30, 31, plus the pointer p. The pointer p increments, so it's going to be 10. Okay, let's go 44 and we'll move on because we don't have very much time left. Claretto, hello, nice to see you here. What is up? Okay, so what happens if we try to compile this program? So our options are 4, 3, and 6. Print I at the end. So I is 1, j is 2, and pointer p. P equals dereference of I. Pointer p is equal to j, and j is 2. J is 2, and then becomes 2 times j. 2 times j. So 2 times j is 4. I equals p. So this is also 4. So 4. I'm going to guess 4. Okay. I get the feeling that I'm going to get a lot of questions wrong here, but I guess we're going to have to look through the code and try to figure it out afterwards. Okay. I mean, Tattletale, I don't know. Can you give us a definitive link or like some sort of article that talks about C programming and like dogs and stuff like that? Because we've been talking about this stuff for a while. Okay, so our options are 2, 5, and 7. So T is an integer array with 5 elements: 1, 2, 3, 4, 5. Pointer 1 and pointer 2, and s equals 1. Pointer 1 is the dereference of t, 0. The dereference of t0 is 1. The dereference of t4, which is p2, is 5. So 1 and 5. So p1 is 1, p2 is 5. We're printing out s. So it's like, shouldn't this be 6? So s is incremented. Oh, s starts at 1. So it should be, so 1 plus 1, 2 plus 5 is 7. Okay, a book written by the creator of C. Do you know the name of the book? And can you identify the creator of C? So when you say the creator of C, are you talking about... So there's a couple of creators of C, right? I think one of them is Ken Thompson, and the other person is... I mean, we can probably look it up really quick. C language creators. Dennis Ritchie? Oh, okay, okay. It's just Dennis Ritchie. So not Ken Thompson. Okay, let's go back. So this question here, we've got a bunch of strings. So we're printing out S. So we're printing out the number equivalent of S. Character T20, so it's a bunch of letters. integer s equals the string length of t. So the string length of t is 11. So this is 11 characters long. So t element 3, which is the fourth letter, has a null byte put in its place. So s equals string length of t. So string length of t becomes 0, 1, 2. So that's three elements long. So it's 3. So print s, so it's 3, okay? Let's move on. We have 10 seconds left. Not going to be able to answer these last 3 questions. Okay. All right, my score was 50%. All right, we're going to have to take the quiz. We're going to have to take the quiz again. Okay, so we'll review the questions that we've done already, and then we'll, I guess we'll mark those down. When does null equal 0? So in C, all strings are null terminated. So in so one way we denote that is like, was it /00 or something like that? Or what was that character they used? Okay. Null isn't 0, it's empty. It isn't 0, it's empty. That's true. So it's like /0. So /0 is what they use to terminate all of the strings. So in C, when the compiler sees a string, and they'll read up until the /0 character. Okay, so let's review the test. So we'll just review up until question number 7, because that's where we got to. Okay, this one is incorrect. So the program is supposed to output 2. Okay, so let's think about why this program outputs 1. So it starts as 0, right? So I equals 0. It runs until I is less than 10. So I equals 0. Case 0 is J++, and then break. So I mean, so the right answer is J is supposed to be 2. J starts as 0. When the loop first runs, the case is 0. So it should, J should become 1, and it should break. But why does it say that it the program should be outputting 2? You know what? Let me try typing this out and running it in another compiler. So what's default? Default is J minus minus. J minus minus is for everything that doesn't fall inside the case. Okay, so int I j equals 0. So if anybody can identify exactly why the program outputs is supposed to output 2, let me know. It's going to be a big pain in the butt to print this all out. Actually, wait, can I look at this in here? No, maybe not. Okay, so do a reduce. What's going on? So Anarchist says C actually doesn't actually have a proper first class null, or didn't. C23 fixes it. So null largely is 0 in C. In something like Java, null is empty, not a specific value like 0. Starting in 0, thus break. Starting in 0, thus break. Yeah, I mean that's what I thought, but the test results say that the program that the correct answer should be 2. So J starts as 0, and we're supposed to find what J is at the end of the program. So I equals 0, so I is 0, and then we start. Switch case I is 0. Case is 0, J increments, and then break. So J should be 1 when the program ends. You know what? I'll just record this. So Q1 is supposed to be 1. Q2, let's take a look. So question 2. I got this one incorrect as well. All right, let's see why we're incorrect here. So we're printing out I, and I guessed 12, but the answer was supposed to be 13. So let's take a good close look at this. So T element I is going to be 2 times I. So it starts as 0, then 2, then 4, then 6, then 8. I equals 0, J is 1, and then I is 2, and then J is 2, plus I is 4, and J is 3. I is 6, and J is 2. I is 8, and then J... So wait. Am I incorrect in thinking that like when the break statement happens, the entire loop is terminated? There's a second loop? Try code in Python in console. It's asynchronous, meaning that all cases run. So all of the cases go. Okay, so we're dealing with another for loop here, and what break? Both loops run complete. Oh no, I was talking about the previous question. So the previous question over here. So there are these switch cases. So there's case 0, case 2, case 4, and then default. I mean, I was under the assumption that because I starts at 0, the first iteration of the loop is case 0 and then break. So J iterates and then break, which means that the rest of the stuff doesn't run. Am I incorrect? Break stops follow through. Oh, okay. So it doesn't stop the entire loop. Okay, so I equals 0 means that J increments. And then I equals 1 is default. So default is J decrements. So J is 0, and then in the third loop, oh, right. I increases by 2 each time. Yeah, yeah, I increases by 2 each time, not by 1. So I equals 0, then I equals 2. So in the case of 2, j increments, and then does the rest of this code run though? So just 2 should run, and then maybe default. I mean, I'm not sure. Writes and notes like haven't been imagined. Organize the flow. Okay, let me just try doing this in like another compiler. So int I j equals 0 for. It's too bad I can't copy paste this. There's no case for 6 or 8. So I mean, in the case where there are no cases, it just defaults. So there's case 2, case 4, and then we print f d. So the max ever gets to is 6 and -2 twice. Fallback works by continuing with the next case until a break or until the end of the switch block. Okay, let's go ahead and run this in another compiler. So like C language online. So this is like GDB online debugger. Okay, let's use this one. And this is exactly what we're using, yeah. Okay, so this is our program here. Okay, so I think this is the program here. So we'll just run it. 6 minus 2 minus 2 equals 2. 6 minus 2 equals 2 equals 2. ITC only makes it look nice for the humans. The program doesn't care. Yeah, it doesn't care about white space. Oh, I forgot something. I forgot to remove the break here. All right. Reset the program, run it again. Did I write out the code correctly? There wasn't a break on case 2, was there? No, there was not supposed to be. Let's go back here. So case 2 is j increments. Case 0 is j increments and then breaks. So j less than 10, j increments by 2. Or I increments by 2. You have one break too many, yeah. Hold on. Okay, so ultimately we print out j. So it prints out -5 for some reason. What am I getting wrong here? So integer ij equals 0, for I equals 0, I less than 10, I increments by 2, switch I, case 0 is nothing. And case 0, case O. Case 0. Yeah, okay. Syntax error. So that's like a that's a big typo. So we can do this. There you go. All right, now let's run it. 2. Okay, I guess what we can do after each one of these is we can print out the value of I first. So printf %d, or like just like I is something. So this is a little debugging print statement. Oh, and we should probably put in some new lines in there. Okay. Don't forget the new line. Yup. So I is 0, I is 2, I is 4, I is 6, I is 8. Oh, no. We should be printing out j, because we care more about j. Alright, let's try it again. J is 0, J is 0. J is 0, J is 0, -1. What happened here? J equals 0 at the loop start. So I think I want to put my print statement somewhere else. All cases must be finished by break. So they're either going to be finished by break or they're going to default, right? J is 2. J is 2. When does J become 2 though? J starts as 0. Case 0, J increments, break. Can have 0 breaks and a completely valid switch. I mean, the breaks... So I guess... Oh, you know what I think? Okay. Does J become 0 each time the loop runs, though? No, J doesn't reset. So it just runs through all of these. Printf will only run on the default case. You likely want it outside of the switch. So we do want it outside of the switch. So we'll put it here. No, we need to do... Yeah, this is not how we do it. Okay, so we want it outside of the switch, so we want it like over here. Okay, I think we need the braces around our for loop to run the print every time. I think we need the braces around the for loop. Okay, so the for loop... Oh, it doesn't have braces, that's correct. So sometimes you need braces and sometimes you don't. Okay, so these are the braces around the for loop. These are the braces around the switch. Okay, let's see if it runs. So J is 1, J is 3, J is 4. J is 1, J is 3, J is 4, J is 3, J is 2, and then that it ends like that. This isn't Python, indentation doesn't help. No, I mean, I think we've got it. So it's outside of the switch, but it's inside of the for loop. So this seems to work. Okay, so it does seem to be running every time. So every time something's happening to it. So the first time, J increments, and then the second time, J increments by 2. So during the second loop, I is... Well, we should probably print out I as well. So I is something, and then J is something. So this would be I and then J. Okay, we'll run it again. So I is 0, J is 1. I is 2. I is 2 because it increments by 2. J is 3. So case 2 is I plus plus, and then... Wait, why does J increment twice here? So the second part of the loop, I is 2. So case 2 is J increments. And I guess this instruction goes off as well. So increment, increment, break. So this is plus 2. So 1 plus 2 is 3. And then 4. So case 4 is increment by 1. And then case 6 does not exist, so it decrements. So J becomes 3, and then J becomes 2, and that's the final one. Okay, when there's no break in a switch, it falls through. Yeah, it seems to... Well, I'm beginning to understand. Okay, you don't need braces if it's a single statement, but a lot of style guides will tell you to always use braces to avoid issues like that. Yeah, for sure. Okay, I think I understand now. All right, we'll go back. So we'll move on to question number 2. So question number 2 is... So this integer array, t, it's got 5 elements. And we're populating the array over here. So for I equals 0, I less than 5, I increments t element I, so it starts as 0, then 1, 2, 3, 4, 2 times I. So we were talking about this. So this runs 4 times. So t is 0, t element 0 is 0, so I guess we can t element 0, t element 1, 2, 3, 4. But it doesn't run 5 times. It only runs 4 times, I think, right? So I less than 5. So it should only run... No, it does run 5 times, right? Right. It does run 5 times. Okay, so we populate the array. And then we do something. What do we do? Which job? What are the breaks for? Oh, I mean, you're talking about the previous question, right? So in the previous question, it should run through all of these instructions. So case 0, case 2, case 4. But it starts at different places depending on what the I value is. The break just means to stop. So if at case 0, it does J++ and then break. But if it's case 2, then J++, and then it runs to the instruction for case 4, so J++, and then break. Whoever does this, well, I mean, if you're interested in doing... I mean, we've got a bit of time. So who benefits from learning C in cyber? Reverse engineers. So I mean malware analysts, malware researchers. That is like malware authors. So I guess malware researchers, we can also call them like malware developers. And who else? Yeah, so mostly people who do reverse engineering and people who do like malware development. Do it, but not for a job. Man, Vita BTS, hello, nice to see you here. Are you working on Ubuntu? No, we're working on Kali Linux. So Kali Linux and Ubuntu are kind of similar because they're both derivatives of Debian. Debian Linux. So Kali, you got Ubuntu. You got Linux Mint. And I'm not too sure what other like really famous distributions of Linux run on Debian. Let me know. Insert a new Linux copy paste here. Yeah, kind of. But I mean, also people who are fans of the Linux kernel are also, well, I mean, specifically people who want to write Linux exploits. Linux kernel exploits developers. So you should learn some C, because all of the exploits for the Linux kernel are all written in C, because the Linux kernel is written in C. MX Linux, Raspberry Pi, OS2, other famous ones, okay. What are the main differences between each version of Linux? I mean, I'm not really the person to ask about this. I think the major differences between the versions of Linux are basically the package managers. So the package managers, and I don't even really know what the difference between the package managers are. That's not really something I learned about. Okay, I'm already in your DC. DC? Domain controller? Are you, what are we talking about? Okay, Dragon, Kali, smarter choice. Alright, so let's go back. So we populate the array with these values. I equals 0, for I equals 0, I less than 5, so it happens 4 times. I plus equals ti. So we're basically adding up, right? So it's 2 plus 4 plus 6 plus 8. 2 plus 4 plus 6 plus 8. That's 14 plus 6. So that's 20. So I should be 20. Oh, okay, Discord. Yeah, if you want to be part of the Discord, here it is. We also have a Reddit. I guess it, I guess it was 20, but actually we're talking about like the element number. Right? So if it's just if we're just adding element numbers, then we're not talking about 2 plus 4 plus 6 plus 8. We're talking about 1 plus 2 plus 3 plus 4. So 1 plus 2 plus 3 plus 4 is 10. But the answer is not 10 either. So I don't quite understand. The correct answer is supposed to be 13. Oh, I guess we start counting from 1 in this case. So 1. So 1, 2, 3, 4, 5. No, we had 0 plus 0 plus, and then 1 plus 2 plus 3. Then 0 plus 0 plus 1 plus 2. Two is, I equals 2 is skipped. I plus equals t. We're modifying I in the loop. Oh, yeah, right. Yeah, this is, okay. This is tricky. All right, let me write it out. So I equals 4. I plus equals t of I, and it's I equals 0. I less than 5. I increments. Okay. So the first loop I is 0. Because it's 0 plus 0, right? And then in the second loop, I plus equals, so I equals 1. So I equals 1 plus, and then we add t of I. So I is 2, 1 plus 2. Then I equals 3 plus 3 plus 6. So while I is less than 5, so this is the last iteration. So 3 plus 6 is 9. No, I is I plus 9. So it's not 9, it's 12. 9 plus 3. Because we have to factor in the previous one. That's why you don't modify your iteration in the loop body. Yeah, I've done this before. And I wondered why my program was going weird. So this is first loop, this is second loop, this is third loop. There's no fourth loop. So it's actually 3 plus 6 plus previous. And previous is 3. So 3 plus 6 plus 3. So that's 12. So that makes sense. But it says that the program's supposed to output 13. Hold on. Wait. How does it output 13 then? Okay. When I said what? You're forgetting a plus plus somewhere. Okay. Let's look back at the code. Plus equals t of I. I less than 5, I plus plus. So I guess I missed out on a... Oh, you know what? So previously I equals 1. So in the first loop I iterates and becomes 1. If we add 1 plus 2 and then the previous one as well, then this would be 4. 4? And then 9 plus 4 is 13. Okay. So that's why it's 13. I'm keeping track of these questions Where'd I put that thing? So question 2 is 13, question 3. I think I got this one right. Is that a bot of my viewers? I don't know. Who do you think the bot is? Okay, let's move on to the next question. So question 3, I got this one right, and the program output's 10. Program output's 10. Okay, we'll just record this because I got this one right. Question 4. It's me, I'm the bot, beep boop. How are you doing tonight, Zamru? What are you working on? Are you working on any, or are you, like, chilling out tonight? Let me know. Okay, question 4 is, I also got this one correct, so I'm not going to pay a lot of attention to this. So that, actually, I should pay attention to this one, because this has to do with some pointer stuff, and I'm not good at pointer stuff. You had 9 viewers. I mean, the numbers kind of jump around all the time. I don't think you should pay all that much attention to it. Okay, so int I equals 10, j equals 20, pointer p, and s equals 0. P equals dereference of I, and then I iterates, or I increments. Pointer p increments. S equals I plus j plus pointer p. Can you see who is in the viewers if they don't comment? Yeah, I can. Currently I'm working on getting the baby to go to sleep, to be determined on success. Well, I mean, good luck with that. I don't know about YouTube. Let me see if I can open up the list of viewers on YouTube. I mean, I can take a look at the chat. Oh no, I can't see the participants. So there's only 1, 2, 3. There's only 3 viewers in my YouTube chat right now. Well, I mean, maybe a couple more with some of the legitimate bots. Printf s turn 0. Okay, let's go ahead and do this in here. And now it's 1 more. Okay. Let's make this a little bit bigger. Okay, so let's try to understand what's going on here. So I equals 10, j equals 20, pointer p, and s equals 0. So this is a dereference. Dereference of the I variable. So this would be, this means that it's the value 10, right? Probably a hacker. Are there hackers in my YouTube chat? Okay, I increment. So here I equals 11, and then here we've got pointer p increments. Pointer p increments, which means that p is also should also be 11. So the last thing here is s equals I plus j plus pointer p. So I is 11 plus j, which is 20, plus pointer p. Pointer p is 11. So according to this math, it's supposed to be 42. Wait. Did I get the answer for it? Actually, you know what? We'll just run the program and it'll tell us what it's supposed to be. Forgot a semicolon. Okay, run it again. Now I forgot another semicolon. All these semicolons. Okay, let's run it again. 44. 44. So where did I miss off the extra 2? Russia? I don't know if anybody... Oh, hello, nice to see you here. I don't know how to pronounce your name. Let's see if I can get a quick Google Translate. Alexandra. Alexander? Let us know which one it is. Thank you. Okay, I and p are the same variable. So I and p are the same variable. So I increments, so I goes from 10 to 11. And pointer p increments. So I is equal to 11. Then goes to 12. So the pointer p is 11 and then becomes 12. That name is 100% gibberish. I just spammed the keyboard while making it. Oh, okay. But why? So pointer p is 12. I mean, the question, why 44? So I guess the easiest way to do this is just to print out this stuff here. Just print f at all of these at all these places. 12 plus 20 plus 12. 12 plus 20 plus 12. Wait, does this influence I? So when the pointer p increments, does it affect the value of I? So p, let's just print out p here, like p is something. And then same thing with this. I is something. And the last one, pointer p is, or like pointer p is pointer p. P is incrementing the value pointed to it by p. That is I, not the pointer itself. Okay, so I guess we also need to make sure that we've got line breaks after all these. Okay. What happened here? So when we print here, dereference of I. Oh, this has to be like a memory address or something, right? P is a pointer. Okay, and then here I is equal to 11, which we predicted. And then pointer P is 12. Okay, and is the address of or reference, not the dereference operator that you have in that comment. Oh. Is the address, okay, so the address of I. So the address of I, the I variable, which is, we don't know. Oh, the dereference operator, right. So the difference between dereference and pointer, I guess I need to, comment says 11. I mean, this is correct. This is not correct because I becomes 12 and the pointer is also 12 because the pointer points to P. Sorry, the pointer points to I. So they're the same thing. So in this case, it's 44. But I just kind of guessed at that answer. Okay, let's record that. So question 4 is 44. Question 5. I also got correct, but we'll take another look at this. So we're printing out I over here. Okay, so I need to understand this, what these pointers are pointing to. Let me type this out and then we'll examine it. Int I 1 J2 pointer P equals address of I. Pointer P is J. Pointer P is 2 times J. I equals pointer P. Printf decimal I, return 0. Okay. We'll replace our program, fix up the indentation. Okay, let's comment this. So P is the address of the I variable. Pointer P equals J, and J is 2. And this is pointer P equals 2 times J. So here pointer P is J times 2, which is 4. And now I equals pointer P. So so I equals 4. Because pointer P is 4. Print out I. So I is 4. Okay, we'll double check this. Nope, because what did I do wrong here? So this is line 7. Oh, okay. Another missing semicolon. 4. Okay, so this was pretty straightforward. So record this. So question 5 is 4. Question 6. I think this is the last question. No, we got up to question 7 before we ran out of time. Okay, so what happened here? So let's see, I got it right. Program output 7. Ah, okay. You know what? I should probably type this all out too, because I really need to get better at arrays and pointers. So int t, 5 elements. It's going to be 1, 2, 3, 4, 5. Integer pointer p1, pointer p2, and s equals 1. p1 equals address of t element 0, and 2 address of t element 4. S is incremented by P1 plus P2. Printf percent D, which is S. Okay. So this is 1 plus 2 plus 5 equals 7. Let me break it down. Okay, so there's a pointer P1 and a pointer P2, and S equals 1. So let's talk about what these values are here. So pointer 1 is the address of t element 0, and t element 0 is 1. So P1 equals 1. And P2 is address of t element. It's updog. It's updog. Of course it's updog. So P2 equals element 4. So element 4 is the value is 5. So here we've got pointer 1 and pointer 2. So pointer 1 and pointer 2 is 1 and 5 respectively, so it's just 1 plus 5, and that's 6. Wait, didn't we have 7? No. S starts at 1 up here. So it's 1 plus 1 plus 5, which is 7. Is that it? Okay, we'll run the program. Always missing a semicolon. Okay, 7. Great. Amen. Hello, nice to see you here. What's that? What's what? What is up, dog? What's up, dog? Alright. So this was question 6. The answer is 7. So this is the last question we did before we ran out of time. So we'll look through this and then we'll start the quiz over again. Okay, this is the string one. If you're not always missing a semicolon or even writing C, learning pointers, yeah, trying to understand pointers, it's been tough. Character T is 20 elements, and it's going to be A, B, C, D, E, F, G, H, I, J, K. Integer S equals string length of T. T element 3 equals 0. or null in this case, I guess we'd call it. S equals string length of t, print S, printf, E1, I think 3 actually, wait, what? T element 3, so T element 3 is the 4th element. Well, we'll talk about this in just a sec. But E1, hello, nice to see ya. So let's see, it's %d, we're printing out S. No, I mean, we'll talk about this over here. Okay, so the program, we'll just paste it in. Okay, so we've got our string. So a string is an array of characters. String length of t. So string length of t is 20. So S equals, well, it's not 20. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So because there's 11 characters in this array, so this instruction over here, T element 3, so this is 0, 1, 2, 3, so the letter D is replaced with null. So this means that the string terminates here, essentially. So this means that the string length of t now is 3. S equals 3. Okay, so we'll just try running the program. 15. Oh, you know what? We need to put in an extra string.h. Is it string.h or strings.h? Strings with an S. Okay. Is it string? Okay, it's string, not strings. Okay, so yeah, so that means that the answer is 3. Okay, let's continue on then. So we'll just run the test again, because we ran out of time last time. So retake test. So we know these answers. It's like 1, 13, 10, 44. And then 4, 7, 3. And now we've got to do the last 3 questions. Eamon says, include strings.h is missing. Pleasant C, you can't even change a character like that, will generate an error. Okay, so we're working on the 3 questions we weren't able to answer last time. So this is another string one, right? So character array T is at maximum 20 elements long. 1, 2, 3, 4, 5, 6, 9, 10, 11. So there's 11 characters here. So S equals 11. T equals, isn't this the same thing? So S is the string length of T, and then we add the string length of T. So that's 11 plus 3. So 11 plus 3 is 14. Okay, what happened? Yeah, because we need to pay attention to the plus equals over here. Okay, so we have 2 questions left. So we got 0, 6, or 3 as our answers. Character array T, maximum size 10, is empty string. Integer S equals string length of T, so string length of T is 0. String concatenate T, A, B, C, D, E, F. So S equals 0, and then we populate the character array with 6 letters. Reading, once again, is proven overpowered. Reading is a fundamental skill. Okay, so 0 plus 6. 0 plus 6. There you go. Okay, last question. Okay, Tattletale, I mean, yeah, I wouldn't tell too many people in like a public setting that you hate dogs, because a lot of people really like dogs. So it's it might make you unpopular with a lot of people. Anyways, what are we talking about? So let's see. So that's 11 letters again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. S equals string length of T. So that's 11. And then we cut off at the 3rd letter. So 11 plus 3. String length of T is 3 plus 11. So 3 plus 11 is 14, and then we add so string copy, so 14, and then we put in 6 fresh letters, and then we add the string length of T. So that's 14 plus 6, so that's 20. And then we add on 3 more letters. So the string length, so 20 plus 9. So the program should output 29. Let's not talk about doing bad things to animals, please. Thank you very much. Although people do eat animals, so it's just that it's socially acceptable to eat some animals but not others. Okay, submit. Wait, did I not finish question 7? Hold on. Question 7, the answer is 3. Okay, back to review. Review screen. Okay, submit. Are you sure you want to submit your assessment? Yeah. 90%. What did I get wrong? Okay, let's review the test. Wait. Did I? Oh, I put this in wrong. The answer was supposed to be 2. Silly me. Okay. Anyways, we can go back to the summary and finish this out. Okay, we've got more tests. Oh, dog lover? Well, I mean, the animals that I love are birds and frogs. Well, more birds than frogs. Anyways, and people eat some birds. Okay, I guess we're taking another test. So 30 minutes, oh, we've got 20 questions. We need to score, I guess we need to get at least 14 out of 20 right. to pass this one? Okay. So what is the program output? So 1 minus 1, 2, or 0? So T, integer array T with 3 elements. So we populate T here. Start at 2. I greater than or equal to 0. I decrements. Oh, okay. So we start at 2, and then we go 2, 1, 0. 2 and then 1. So it only runs twice. So Ti equals I 1. What? T1 equals I 1? What does this 1 do? El Mexicant, hey, what's up? We're just studying some C over here, taking a little test. That's publicly unacceptable too, because you hate birds. Well, I mean, I do like birds, but I also eat birds, so there's kind of a incongruity there. I like certain. I don't eat certain birds. I only eat certain birds. The acceptable ones. Okay, I've also been learning some C. Awesome, awesome. What are you doing with your C learning, El Mexican? Are you doing reverse engineering? Are you doing binary exploitation stuff? T equals I 1. So Ti, so that's T2 equals 2. 2, 1. I don't get this. So at the very end, we print off T1 minus T, and we've got T element 0 plus T element 2. So T element 2 is 2. T element 0 is 0. T element 2, which is 2, minus T element 1, which I'm assuming is 1. 1 minus 2 is minus 1. So the program outputs minus 1. Okay, so let's see. Pro, nice to see you here. Would be doing C but in class right now. You must be in Asia somewhere. Mexican says pretty much, but mostly because I wanted to learn a low-level language in order to get a better understanding of it. I mean, there's lots of fun stuff you can do if you learn C, including stuff like binary exploitation challenges, like buffer overflow stuff. That's why I'm learning it. And also so I can learn how to do reverse engineering and, like, you know, and pulling apart binaries. Should be a lot of fun. Okay. That took a long time to do the first question. Okay, so character array, S, 10 elements, A, B, C, D, E, so that's 5 letters. String cat, so concatenate S plus 2, S plus 2. S is an array. So S plus 2, so I guess add the number of elements of the array, so S with 12 elements. And that's like 10 elements large. Okay, yeah, I see. I've done buffer overflows, which is what got me curious. Honestly, I like the questions better than writing the code. I like the questions better than writing the code. I mean, the questions are, they make you think about what's actually going on in these programs, right? So it's, so S, character array S should have like 10 letters. So A, B, C, D, E twice over. And then we print off S0. So element 0 is A minus S element 2. S element 2 is C. So if you subtract those two, so it's like A minus, it's basically minus 2. So the program output's minus 2. Because we're basically rendering each one of these characters as a decimal number. Question 3. Okay, we won't get fooled by the switch statements this time. I mean, Telltale, I mean, you can hate it all you want. You don't need to repeat yourself over and over again, of course. I'll just remember that you don't like C. So I equals 3, j equals I minus 2. So I minus 2 is 1, so I is 3, j is 1. Switch I plus 2. So switch 5. I plus 2. So I is 3. I plus 2 is 5. I mean, it's okay. People can not like the thing that's being covered on the stream. It's just that they don't have to keep on talking about making the same comment again and again, that's all. Okay, so this program is going to either output 4, 3, 2, or 4, 3, 1, or 2. Because we're printing out J. Oh, J is I minus 2. So it starts off as 1. Switch case. The default is J equals 0. So I guess if the case is I plus 2, then I is 5. And there's no case for 5, which means it's default. Which means... But 0 isn't an option here. I gotta be missing something. So the switch is I plus 2. I is 3, plus 2 is 5. So the case is J equals 0, and then J increments. So J is 1. So the program outputs 1. Okay, this one is much simpler. So character array 10. S is up to 10, so it's 5 letters. String concatenate S plus 2, so that's a maximum of 12. And then we repeat those letters. So S contains 10 letters. And then we print off S element 0, which is A, minus S element 2, which is C. So it's basically 0 minus 2. Question 5. Integer I and integer array t contains 5 elements. So t element 0 is 0, and then for I equals 1, I less than 5, I increments, t of I equals ti minus 1 plus I. Oh. What is this? T of I. Okay, so T of I, we're basically populating the array. This one's kind of tricky. Let me think about this. So T... So let's just say that I equals 0 and then I equals 1. So T of I, well, I mean, I starts at 1, right? So T of I, so T1 equals Ti minus 1. So it's 0 plus I. So T element 0 is 0. Add I means means 1. So if we expand it to this, so T1 is 1 plus 2, 3. So basically T element 1 is 1, T element 2 is 3, T element 3 is 3 plus 3. So this is 6. How many times do we need to do this? So we need to do this 1, 2, 3, 4 times. So it's 6 plus 4. So 10. So what do they want us to print out at the end of the program? So T element 4. So T element 4 is 10. Okay. Question 6. This is only question 6. Okay. What happens if you try and run this program? So we've got... oh, okay. We're dealing with the scientific notation here. So T is a floating point array with 5 elements. So it is IE0, IE1, IE2, IE3, IE4. So I to the power, so 1 to the power of 0, right? IE0 equals 1 times 10 times 0, which is 0. And IE1, 1 times 10 times 1, 10. IE2 is 1 times 10 times 2, so that's 100. And we keep on going like that. So printing out T0, then T2, and then T3. So T0 is this, T2 is this, so that's 100. 100 plus 1,000. So 1,100? $1,100. Wait, why is that on? Am I missing something? So wait. IE0, is that 1? So 1 times 10 times 0. So 1 times 10. Cypher, geez. The turnip, hello, nice to see you here. What's up? What am I not getting here? So 1 to the exponent 1. Is this 1? One times 10. So that would mean this is 1 and this is 10. To the power of 0. To the power of 0, to the power of 1, to the power of 2. And then let's... to the power of 3, which is 100. What are they looking for? T3. T3, 0, 1, 2, 3. So the power of 3 is 100 plus... 100 plus 10. 110 plus 0. I think I've got my scientific notation incorrect here. My best guess is this one. How much time do we have left? 12 minutes? So this is a pretty short program. So character array T, size 3. So size of T is 3 minus size of T element 0. Size of T is 3 minus T element 0, 0. So 3 minus 0 is 3. So integer array T, 10 elements. So the number is from 1 to 10. P increments by 2. We didn't define, where is P defined though? P increments by 2, so I'm going to imagine it's 2. P increments by P minus 1. The turnip says, I'm learning NixOS and how to install it. How is C going? It's going. We're trying to understand some of the finer points of it. But NixOS, yeah, I've heard a lot about NixOS. It's all about what was the thing about NixOS? NixOS special characteristics. NixOS is a unique Linux distribution controlled by a single text file. You write down what you want and the system builds itself. Oh. I have no idea. I have no idea what this is. Ultimate separation and reproducible builds. I guess it's for people who really want to be super granular about what they put in their system. I mean, I guess... It sounds fun. I mean, I don't know if I'd be willing to dive into NixOS, but I'm sure there are a lot of people who would, including our friend the turnip. Okay, where were we? Over here. So P We're printing out P though. We're printing out the pointer of P. Pointer P. So pointer P is oh, I didn't see this. Okay, so we need to scroll over here. So pointer P equals T. So it points to the beginning of the T array, and the beginning of the T array is T1. So T1 and then increment P by 2. So it becomes 3. And then P minus 1. So P minus 1 is 2. Okay, so if the pointer P points at T, it points to the beginning of the T array, which is here. The turnip says, my goal is to make a setup where I can make VMs easier and not have to configure Linux the way I like each time I make a new one. I mean, that's a pretty good goal. If you're making life easier on yourself by learning NixOS, then it sounds like you're learning it for the right reason. Okay, so it points at P equals T, so this. Then we increment by 2. Then we increment by P minus 1. So P minus 1 is 2. Which is over here. So P is T element 0, which is 1. So the program outputs 1. I could be wrong. Okay, so let's see. Integer array T, 2 elements. T element 0 is 1. T element 1 is 0. What is this alphabet? What is this soup over here? So print. What does this even mean? So T0. So T0 is 1. 1. T1 is 0. Oh gosh. Okay, so Anarchist has been playing with Nix myself. It's cool, but I decided to skip NixOS and just use Nix. I've got Nix running in an Arch container, managing my home directory and spinning up declarative dev shells, but keeping Arch for all the low-level stuff. Not really sure that Nix for system configuration buys you all that much, so I think Nix is just a nice middle ground. I mean, I'm not too sure what the difference between Nix and NixOS is. So is Nix like a package manager? Nix versus NixOS. So Nix is a functional. Okay. So the package manager is called Nix. NixOS is the Linux distribution built on top of the package manager. Nix is a programming language. It's a programming language. Huh. I mean, is the AI summary incorrect then? I'm not sure. Oh, it's a language. Okay, so it's a package manager and it's a language. They're both called Nix. Okay, let me try to unpack this problem I have over here. So it's T 0. So T0 is 1, but T1 is 0. It's 1, it's 0, it's 1. So the answer is 1. The program outputs 1. Okay, done. Okay, Turnip says, if Nix can be used with Arch, I might just go that route then, because I already know Arch. One of these days I should probably teach myself, I should probably try to install Arch on stream. Maybe I'll do it for like a milestone or something. Although I don't know if I'd have a good time with it or not. Okay, what happens if we try to run and compile this program? I equals 1. Pointer j is the address of I. And what's this double one here? Have I learned this? I hear it's way easier now. It used to be insane. Arch is neat. I've been thinking about putting it back on my laptop. I mean, I guess the ideal way to experiment with some of this new stuff is to use like a separate device, not the device you usually use. Arch even has an installer now, so you don't have to go through all that command line stuff. Didn't people used to use like scripts to install Arch? I helped my buddy do it when he didn't even have wizards. Okay, I need to refresh my memory what this double asterisk is. C language double asterisk. This token does not mean exponentiation power. Instead, it refers to a pointer. Represents a pointer to a pointer, a double pointer used for direct memory manipulation. It's a pointer to a pointer. Okay, sure. So it's integer 1. So I1. Pointer j is the address of I. Pointer of pointer k is the address of j. Printout pointer of pointer k. This pointer is all the way down. So the pointer of pointer k is the memory address of j, and j is the memory address of I, and I is equal to 1. Could it really be as simple as just the program outputs 1? Okay, if you're not spinning up across a lot of hardware where you need to share the low-level hardware config across machines, I think just using Nix and Home Manager rather than Nix OS is a nice midpoint. If running on something like a laptop, then choosing a base distro based on hardware support might be more helpful than being stuck with Nix's system package state. Okay, we've got an answer. We'll move on. We've only managed to get halfway through these questions. What happens if we try to compile and run this program? Character array T is equal to AB and AB, so capitals and lowercase and then capitals. Print out T1, so B minus A. So B minus A is 1. 1 plus three, which is this one, so B minus A. So B minus A is also 1, so 1 plus 1. So print 1 plus 1, so that program outputs 2. Okay, I'm probably not going to be able to answer this one. So So character array S is, what is this? So it basically stops right here because it stops at /0. So A plus S3. Okay, I scored 8 out of 20, which is 40%. All right, let's review our test. So we got up to question 8, did we? Okay, we got this one incorrect. Seems like it's the pretty common thread of the evening. I don't get any of these questions correct. Okay. So integer I, and then array with 3 elements. Then 4 ti equals I 1. What does this 1 mean? Then printf %d t plus t2. Yeah, this is confusing. Let's take it apart. Hold on, I copied this down incorrectly. So for I equals 2, I greater than or equal to 0, I decrements. So we're populating the T array. So T0. Well, first we do T2. So T2 and then T1. So I is greater than or equal to 0. So T0 does happen, right? So T2 equals I1. What does this 1 mean? I actually don't quite understand what this does. So I, which is 2, 1. All right, so what was the answer supposed to be there? So I think I might understand better if we just do like a print statement here. Print out a decimal. T element is something something. So T element I and TI. Add braces to put printf in the for loop. Yeah, that's what I should do. Okay, we'll go at this. We'll do this for another 60 minutes or so. We'll see what we're at after 60 minutes. Hopefully we're finished with the test, but we'll see. And then I can move on finally to the next next module. Okay, so the for loop over here, let's put our curly braces in. Let's just delete this. Here. All right, let's give it a try. Oh, 17. Expected before numeric constant. Yeah. What happened here? Because in the code it says t equals t element I equals I 1. And I don't understand what this does. And this is screwing up the compiler. Okay, so if anybody in chat knows what exactly this code is doing, let us know. Because if I can't get this to compile, I think I'll ask the AI. It looks like an error. You sure that's what the question had? I mean, that's what it looks like. So t element I equals I something something 1. I don't know what it could be though. Okay, I'll just feed this thing to an AI. Maybe it can understand what's supposed to be going on. Can you copy and paste the check it's not some HTML oddity like black text? Oh, you know what? That'd be... Okay, let's... Well, I mean, I can't copy paste this either. I think I've got like dark mode on. Maybe see if I can reset the dark mode. Dark reader. We'll turn on dark reader. Ah, that hurts. I mean, it looks like it's just missing. Okay, let's turn dark mode reader on. Oops. Okay, Perplexity. what's going on with the spaces between the I variable and the number 1. Looks like just something missing, given no copy paste. Only option would be it's a syntax error. There's no valid operator punctuation between them, so the compiler will reject this line. Missing operator. So I with just a space is not valid. The compiler expects something like I plus 1. Given typical exercises, it's almost certainly meant to be ti equals I plus 1, or possibly ti equals I. Okay, so what did they say the proper answer was supposed to be? So this is incorrect. So the problem, the question, this is supposed to output -1. Okay, so if this program is meant to output -1, then what would the line of code likely be? Okay, if the goal is to output -1, then the likely line is I minus I. So I minus 1. So to reproduce -1 in the final expression or intermediate step, you typically subtract 1 from I as it goes from 2 to 1 to 0, mapping to t values that yield the desired result. Okay, so let's take a look at the code one more time. So if this is supposed to be -1, we're populating the T2, and then T1, and then T0. So T2 equals 2 minus 1. So 2 minus 1 is 1. 1. T element 1 is 1 minus 1. So 1 minus 1 is 0. And T0 is 0 minus 1, which is -1. Okay, and they want us to print out T element 1, which is 0, minus T element 1 is 0, minus T element 0, which is -1, plus -1 plus 1. -1 plus 1 is 0. Wait. -1 plus 1. 0. So 0. So T element 0. So T element 0 is -1. -1 minus 0. -1 minus 0, I guess that's -1. Okay, let's just record the answer, because it's giving me a headache. So question 1 is -1. Question 2, let's go back. We got this one correct. Okay, so because we got it correct, we'll just record the answer. and then we'll move on. So this is -2, because we need to save time when we can. Question 3 is also correct. Okay, so we'll just record the answer. So this is 1. Question 4 is also correct. So this is -2. Well, I'm glad that I'm getting some of these questions correct and I'm not, just incompetent. Question 5 is 10. Question 6 is 1001. 1101. Question 7 is incorrect, so we need to take a closer look at this program. Okay, let's take a closer look. Character array T, size 3. Printf size of T minus size of T element 0. Okay, let's figure out what went wrong here. So size of, is this part of some specific header? I guess it'll tell us when we try to run this thing. Ah, semicolon. 2. Size of T. The size of T is 3. Because it's specified over here. So it's 3 minus size of T element 0. T element 0. T element 0 doesn't have anything in there though. So size of... Okay, let's do some debugging. Printf, 2 things. The size of T is size of T. And the size of T 0 is size of T 0. Okay, let's see what happens. The size of T is 3. The size of T0 is 1. Oh, it's 1. I guess it's, in this case it's like 1 byte. Because it's a character array. So character array, each element is going to be 1 byte. And if we're measuring by bytes, it is 3 minus 1. So one element is 1. The total size is 3, so that's going to be 2. I mean, that makes sense. Okay, it still has a size even if it doesn't have a value. Yeah, I guess I was getting something confused. I was trying to think of the value rather than the size. All right, so let's go on to the next thing. Question 8. So did I? Yeah, I answered this. Okay, this one was kind of confusing. So let's int t 10 elements. So there's also like the stuff at the end over here. So there's also a pointer. So pointer p equals t. There's also p increments by 2. And then p increments by p element minus 1. And at the end, printf decimal, which is the pointer p. All right, let's go back. All right. CHJ Woo. Hello, nice to see you here. Hope you're having a good night. We're just doing a little bit of studying over here. So integer array t, it's got the numbers from 1 to 10. Pointer p is equal to t. So the pointer, when it points to an array, it points to the first element. So the first element is the number 1. Then p increments by 2. So that means that p is equal to 3, because it starts at 1 and then it increments by 2 it goes to 3. And then p increments by p minus 1. This is where I'm not really too sure. So it increments by p element minus 1. So it's currently this. So does p equal 2 now? So the pointer p should be 2, but I'm not sure. All right, so if we just run the program, it says that the answer is 5. So is this one is also over here? No. Wait, which one was the right answer? It doesn't tell me what. Did I write this out correctly? So it looks like it's trying to say that the program should output 1. But when I run the program in here, it outputs 5. But I thought that this would output 2. Yeah, this is confusing. Okay, well, we can do some debugging. P is pointer P. Not pointer B, just P. So P is something. And then P is now something else. I guess, what is this then? So what is this P minus 1? Okay. Pointer P is something. All right. Run the program. So P is some address. P minus 1 is 4. P minus... Okay, Anarchist says P plus equals 2 is advancing the pointer by 2, so P now points to T2, not adding the value that it points at. Not adding the value that it points at. Okay. So P points to T2. I mean, P... Okay, so this is P0. Sorry, T0. Pointer P is T0. Then increments to T2, which is pointing at 3. So P should be 3. Okay, and then we print out P here first. So P is I guess this is a memory address. So P minus 1 is 4. So P should be pointing at T2, which is 3, but why is P element minus 1 4? Okay, Yazanchi says, nice, you're starting with C instead of Python. I'm not starting with C, I started with Python. I started with Python, now I'm learning some C. Anyways, let's put on the birds. We haven't put on any birds. Okay, let's go ahead and do that. Where are my birds? Okay. We'll be back in about 30 seconds. I just need to have a little bit of a water break. See you in a bit. Okay, let's put the birds away. Okay, so Anarchist says pointer P should be 3. Pointer 3 P should be 3. P is the address of T2. So the pointer P and P are different things. The pointer P points at the value inside of memory, which in this case is T2. So the array element value is 3. P is an address, so some address in the memory. So this is why it's some weird value. I mean, the question is, why is P minus 1 advancing the pointer? So pointer P is 5. P is now, well, it's a different address. So ultimately, we're just printing out the pointer P value. So the pointer P value is 5. When did that happen? So pointer P, we print this out. It's got the value of 5. At this point, oh, I think I understand. Okay. Listen, Tattletale, stop talking about eating dogs. You should be able to print P minus T to get the index of the T item that the P points to. I think I understand what we're talking about. So T equals 3 here. P minus 1 is referencing the item. So 3. So the item at 3 minus 1 is 2. So T2 minus 1, which is T1, is equal to 2. And then we add that to what P is already, because P is already 3. Which means that it's 5. So P minus 1 is something something, but we also need to print what the pointer P is here. So pointer P is pointer P. Okay. Jungi Hora? I'm not too sure how to pronounce your name. Hello, nice to see you here. Easy. Oh man. These pointers are really making my life interesting. Okay, so P is some memory address. P minus 1 is 4. Okay, pointer P is 5. And then at the end of the program, pointer P should be 5. Yeah, I saw your message after before it was retracted. Jeez, you can't really hide the stuff from the broadcaster. Okay, so this is, I guess this is supposed to be, it says this is supposed to be -1 though. It's weird. Program outputs 1, or was this my guess? Okay. So the other incorrect answers, this is my guess? Question 1. No, because you printed p -1 after altering p, you aren't printing the value used. Is the code written like this just for the sake of the challenge, or people actually write C like that? Like this? I'm not sure. I'm not sure what the standards are for writing C programs. If you program with C, hard projects close to a year, I think memory will become second nature. I mean, the reason why I'm doing these challenges is so I can get better at understanding how program memory is affected, because C is a low-level language which often interacts with the values in memory. So, question 7 is supposed to be 2. We got this one correct. Question... Wait, which question did we get to? So question 8 is supposed to be 5. Question 9, we got that correct, right? Question 9, we got that correct, and it's the answer 1. Question 10. This was the last question we answered, and we got this one correct, and the answer was 1. Wait, we got this one correct? I guess we did. So the program outputs 2. Okay, so I didn't answer anything for this. You know what? Just for fun, we'll answer these questions slowly, because we got 8 questions left. We'll reason through this, and we'll try answering these questions. Okay, so let me write out the program. Character S is like... So we print out a character. Character A plus S element 3. Okay, it's a pretty short program. So let's figure out what's going on here. So S, character array S, so it doesn't have a fixed size. Zero, 1, 2, 3, 4. So it basically has 1, 2, 3, 4, or 0, 1, 2, 3, 4 as the contents. Okay, so we print A plus S element 3. So S element 3 is 0, 1, 2, 3, so it's the number 3. The number 3 plus A. A rendered as decimal ASCII plus the number 3. So capital A, I'm pretty sure, is 41 in decimal. No, that's hex. Is it like 68? $65. Okay. So this is going to be 65. 65 plus 3. And that's 68. So my guess is that... Well, no, wait. So that's going to be capital D. Okay, we're going to print, and I think it's going to print out capital D. I think this is capital D. Okay. So the answer is capital D. Okay, we can move on to the next question. 13. Program outputs D. Okay, next, 13. What happens if you run this program? Okay, let me write out the program, then we can play around with it. Character array S, size 10. A, B, C, D, E, A, B, C, D, E. Then we do string copy. S plus 2, and then A, B, C, D, E. Fox404, hello, nice to see you here. What is up? We're just learning some C code because we need to get better at low-level languages. %D S element 0 minus S element 2. Okay, so it seems like a pretty simple program. So we have a character array over here of 5 characters. We add to the maximum size of the array. Or at least I think this is what it's doing. And then we add another 5 characters. Finally, we print off element 0. So element 0 is A minus element 2. So element 2 is C. So A minus C. So A minus C... So the difference is 2. So this should result in like -2. Is a good exploit written with C or C++? I mean, I'm pretty sure you could also write exploits with C++, but the reason why we're learning C is because, well, all of the beginner CTF challenges are written with like insecure C binaries. Okay, so it should be -2. It's 0? Pardon me? Hold on, let me copy the code. We'll reload the page. Okay, run the thing. 0. So print. So we string copied. So element 0 is A minus element 2, which is C. But why does 0 print out? Okay, what programming languages are you proficient in? I mean, I'm currently learning C. I've been trying to learn like a bunch of fundamentals of different languages. The language that I'm more comfortable with is Python. But Fox404, what's your background? Are you a cybersecurity student, or are you working in tech? What's up with you? Okay, so element 0, A, minus element 2. I mean, I guess before we print these out, we should probably just do some debugging here. So maybe like S element 0 is D, and well, what new line? We'll do the same thing for. Did I run out? Okay, we've got more music coming up. And then S element 2. All right, run the program. Nope. You gotta include your semicolons, everybody. So S0 is 65. S2 is 65. Wait, what? Oh. With the string copy. Oh, the string copy. Okay. I think I understand. Game Boy, hey, what is up? So I misunderstood how the string copy happened. So after the string copy happens here, then S equals A, B, and then A, B, C, D, E. Because it starts at the second element, so the first two elements are unchanged. So it's A minus A. So A minus A was 0. Yeah, you know what? I was misunderstanding what the arguments to string copy are. String copy apparently lets you specify where to start copying from. Okay, that makes sense. So the answer for question 13 is 0. Question 14. Okay, so what's this program? So I'll type it out because I can't copy paste from here. Int I-T array of 4. Finally, you're studying C? I mean, yeah, I have to get serious about studying C sometime if I want to study binary exploitation and then reverse engineering. And then we've got a populator, so 4. Send you a message earlier on Twitch. Sent this message earlier on Twitch. Skater Die 87. Hey, Send a message earlier on Twitch. Did you? Hold on. Wait, what's your username on Twitch? ScaterDie87. Oh, I have a question. What network settings are best? NAT or NAT network are best when pentesting your own VM inside your network with the limitations. What limitations should I keep in mind? So you'd probably, I mean, you're probably okay using like host-only networks. You don't necessarily need to use like, yeah, I think you should use host-only networks instead of like NAT networks. Okay, let's talk about this very briefly. So, VM networking settings. Use host-only networks. They can only communicate with each other. They are not internet connected. Well, of course, don't use like host-only networks for your attacker VM. Don't use this for your attacker machine. So basically, your attacker machine and your victim machine should be on host-only networks. And your okay. So that's victim machine on host only, network attacker machine on host only, and I guess you can put it on like a NAT network, because the NAT, well, we're assuming that the NAT networks have like internet connectivity. So the two machines, the attacker and the victim, are on their own host-only network. But the attacker machine can also be on like some internet-enabled network, because you probably need to download tools and other stuff. Okay, Fox404 says, I work as a phone and electronics repair technician. I want to be a web hacker. I learned Python and network now. Yeah, Fox404. So let me give you a link. Get into Cyber. So there's a Reddit link at that link that, well, a Reddit thread at that link that talks about how to get into cybersecurity. But you seem to have a path. You want to be a web app hacker. So if you want to be a web app hacker in particular, I can talk about it very quickly. Okay, so I've got some education resources over here, and you can find those over at this link. Why is this taking so long to load up? Okay, so inside the education links over here, we've got stuff for web app hacking. This has a bunch of resources that you might want to look into. So first you want to learn about what web applications actually are, how websites work, like web requests, web application basics. There's a bunch of links over here to different resources like Hack the Box and Try Hack Me. And when you're ready to start learning, you can start learning with Portswigger Academy, Over the Wire Natus, and PicoCTF web challenges. So the links are over here. Okay, I'm just gonna close out some of these tabs that I'm not using because it's kind of irritating. Okay, let's continue. I heard Try Hack Me is a bit easier than Hack the Box. Basically, Try Hack Me holds your hand, Hack the Box does not hold your hand. Hack the Box is where you go once you've learned a certain set of skills to test them. Try Hack Me is usually a bit more beginner friendly. Okay, I was writing out this for loop. So I equals 0, I less than 2, I increments. T element I is T3 minus I, geez. And then printf. %d T2. So, Fox 404, what I'd recommend is if you're going to be working with web app hacking, I mean, basic skills. So learn how web requests work. Learn basics of HTML. So HTML and JavaScript. So you don't need to learn very much, just some very, very basic stuff about, you know, these kind of web languages. And what else? I mean, Python is good for scripting. But learning how to use like terminal command, what was it? Command line terminal tools like, you know, curl. Learning how to use curl will be very beneficial. Okay, so Anarchist says attacker machine on NAT external network with the host-only network with the target VM is good. Doesn't matter too much in terms of isolation. I assume you trust the target VM, so giving it external network access isn't the real issue. If you want to run untested VMs, that's a whole different thing. Let's see. Fox404 says, I found a 2.5-year web programming program at an institute with a free apprenticeship at a telecommunications ISP, and they give you a monthly salary. I mean, if you can get paid and also get your education, that's a very, very good deal that a lot of people don't get. So I definitely would take advantage of that. But yeah, what Anarchist said about keeping your victim, so the victim VM should not be internet connected, like net connected, or internet connected more specifically. Why? Because, well, especially Windows machines that are victim machines will automatically update, and the updates may destroy the intended security flaws for the box. So I've had this happen a couple of times where a Windows machine that I was attacking was internet accessible and Windows updated, which updated the Windows Defender, and the Windows Defender was able to pick up the intended malware that was supposed to be used to solve the challenge. Okay, VPS is great to use too. Yeah, virtual private servers. Okay, let's continue. Where were we? We were writing out this program. Okay, let's go over here. So let's understand what's going on here. So I is basically your iterator. And then T is a integer array with numbers 1, 2, 4, and 8. Okay, Scatterdice says, Kelly is the attacker, so it'll be on the NAT, which can connect to the internet. Okay. And the target Windows 10 should be on a host only. Cannot connect to anything outside the LAN. Yeah, that's the way you want to do it. Because modern Windows targets will automatically update if they're connected to the internet. So that's why you want to keep them away from the internet. It's a good point on Windows victims and updates. Though ideally on a well-configured Windows victim, it should disable updates. Also on the Windows AD victims, like Game of Active Directory, you often need time syncing, which is trickier without external access. Was a question. Yeah, so your Kali machine should be on a NAT network that can connect to the internet, and the Kali machine should also be on a host-only network. So the Kali machine and the victim machine should be on the same host-only network so that they can talk to each other. Okay, so how are we populating this? So for I equals 0, I less than 2, I increments ti, so we're reassigning. Thank you very much. Oh, that's a lot of numbers and letters. But thank you very much for following on Twitch. Thank you. Okay, does my experience in hardware repair give me any advantages in tech? I'd say it gives you an advantage when you're dealing with... Well, I mean, what kind of hardware are you most familiar with, Fox 404? So I think you were talking about, like, was it telecommunications hardware repair? Or was it something else? If you could reiterate for me, that'd be appreciated. So having hardware experience definitely helps a lot when you're actually doing hardware hacking that involves like soldering and stuff like that. Okay, so T of I, so start at 0. So we're going to repopulate these things. So T0 equals something. T1, then T starts at 0, it's less than 2. So it runs exactly twice. I mean, I'm not super familiar with hardware hacking. I wish I were, but I'd say that it's a loop? Yeah, it's a loop. Okay, so T0 equals T3 minus 1. T3 minus 1. So T3 is 8. Minus 1, 7. So T0 equals 7. And then T1 also equals 7, because it's the same thing. Oh, you know what? I'm sad that I wasn't able to finish the quiz. How many questions do we have left? So this is 14. We've got like 6 questions left. Yeah, I'm not going to be able to finish this. It's going to take an extra hour or so. And I'm not really ready to spend an extra hour on stream. Okay, let's take a closer look. We'll finish this question off. Oh, it's not -1, it's -I. You're right, You're right, Game Boy. Okay, let's go back. So it's -I. So t element 3 minus I. So it's like 8. So t0 equals 8, and then t1 equals 3 minus I, which is 1. So 3 minus 1 is 2. 0, 1, 2. So t1 equals 4. They want us to print out... Wait, what was the point then? Because this doesn't get modified, does it? I'm gonna catch up with C so I can help you with this with the problem sets. Thank you, SkaterDie87. Okay, Fox4 says phone soldering, troubleshooting, and repairing motherboards, and unlocking phones. Currently, we use a Raspberry Pi Pico 2 to bypass iCloud protection passcodes. Huh. Yeah, T2 is never modified by the loop. That's what I thought. So this is just kind of like useless. So T2 stays the same, so this is just 4. Okay, Anarchist says, if you can do hardware repair, then hardware hacking is a valuable skill in some parts of InfoSec. No company is going to let you loose repairing their equipment, but low-level knowledge can be useful. I mean, there's a whole separate like category of hacking of like physical hardware devices, and like the way that hardware devices interact with software. That's not really anything that I've studied before. It's like a whole different thing. Okay, so I mean, let's just ask a very quick question. Where do I learn the basics of hardware hacking? Okay, so recommended, well, okay, what is a recommended YouTube channel? Voltage stuff, weird bus tricks. Okay, Matt Brown for realistic Into the Weeds IoT and firmware teardowns. Joe Grand for reverse engineering and electronics insights. So I think probably check out Matt Brown on YouTube. I've never really checked out his channel before. Let me get the link. Oh, yeah. Oh gosh, what's he called? Let's pull this up. Okay, here's Matt Brown's channel. So he's an IoT security researcher. This is stuff that I know nothing about. So I mean, this is pretty relevant because a lot of IoT devices also I actually don't know very much about IoT devices. Anyways. Okay, let me wrap up over here. So my guess is that T element 2 is just 4. Didn't compile. This is line 20. Okay. 4. Okay. hardware glitching, cool stuff. Yeah, I mean, actually, Fox404, if you don't mind, could you tell me what large city you live close to? Because what I would recommend, if you want to get into like cybersecurity, tips for getting, quote unquote, getting into cyber. So one of the big things is to get involved in your local cybersecurity community. So that is like, in-person meetups. So stuff like your DEF CON groups, your OWASP chapters. So OWASP is like web app security specific. So you might be interested in that because you said you were interested in web app stuff. So DEF CON groups, OWASP chapters, it doesn't necessarily have to be like security focused. Like any tech meetups could have security people involved. And what you want to do is just meet as many cool, techie, how do you spell that? Cool techie / hacker people at those meetups as possible. And talk to them about their jobs. Well, maybe not necessarily talk to them about their jobs, but talk about their interests or their tech interests. Okay, so you just want to make as many social contacts as possible, because a lot of people in security, they get their first jobs through one of their social contacts inside of the security community. Okay, I know SQL injection vulnerabilities in IDOR. Yeah, I mean that's an awesome place to start. And in fact, I think what you could do, you could also like learn a lot over at portswigger.net. They've got their academy over here. And the other important thing that I would learn if you want to do web app security is learn how to use the premier tool from Portswigger, which is called Burp Suite. Because a lot of people learn about web app security through Burp Suite, and it's the most ubiquitous security testing tool in the industry. Okay, so that means that Q14 is the answer is 4. Okay, I'll probably come back to this next week and we'll try to finish these questions, because kind of ran out of time today. Let's make this a little bit smaller. So I'll record these answers over here, and then we'll pick up where we left off last time. Okay, so let's talk about who to raid into, because what's this? infosecstreams.com. This is a website where you can find other people who do infosec streams. So stuff that has to do with security and cool tech stuff. You can usually find, you really can't find a list of people who are online right now, but it does show the top streamers by hours streamed. So I'm at the top for some reason. And there's a lot of really good and cool tech channels in here. Tech channels and hacker channels. Science is on the list. Is it now? Good streams. I like these problems. Well, I mean, they're good learning exercises. Let's see who's online on Twitch. Nullsec says that Science Streams is on. What did I just type? What did I just type? Huh, I don't see Science Streams is online, but let me check out his channel.
10 minutes.
Oh, he is online. Okay, let's go ahead and raid into there. So this is the channel, and we'll start the raid. Science Streams. Yeah, thanks everybody. So we're gonna be back tomorrow. We're gonna be back pretty soon after. We're doing a stream tomorrow, and we're gonna be doing at 2 p.m. to 8 p.m. PST. We're gonna be doing some reverse engineering challenges over at PicoCTF, and we're gonna be starting Linux OS operations. So if you've ever wanted to learn about how to use Linux, because, well, we use a lot of Linux when we learn about cybersecurity stuff, this is the time to join in. And we're also going to be doing more advanced challenges over at Hacker Holidays. So, all right, everybody, when you arrive over at the Science Channel, learn by doing versus watching is the best approach. It's the approach I will be using, breaking and fixing things. Yeah. I learn best by doing. I learn best by doing exercises with predetermined goals and taking lots of notes. Gameboy says bug bounty will soon be run by AI. I mean, the industry is going to have to adjust. So, all right, everybody. When you arrive on the channel, please give this message: OSFrog, hip hop hack, OSFrog. All right, and we'll see you tomorrow at 2 p.m. PST. All right, HackerFrogs out in 5, 4, 3, 2, 1. See you next time.